I'm a principal data engineer at Spectrum Labs for the last 18 months or so. And so the key part of what we've been doing that time frame is setting up these kind of Argo workflows for batch jobs that can be used by our data science team. So I'll go through a couple of demos here. I think the goal is to kind of give an overview of what Argo Workflows is, what it does. I'll show them what we do with it and what we've built around it, like our own SDK and framework to simplify its usage. I'll also give a quick little demo to an Argo events, which is another framework in the Argo suite. I'll talk about some of the challenges that we've had with Argo, as it's all been plain sailing. And then we can talk about some other, perhaps if other people have other frameworks they've used themselves, it'd be interesting to know how it lines up with Argo Workflows. So just a quick overview of what Spectrum Labs is for those who are not familiar. We build trust and safety technology. So a core part of what we do is our deep learning models take conversations from our customers, which would be gaming apps, dating apps, social media platforms, etc. Take those conversations in real time, submit them to our API, and then our deep learning models can detect toxic behaviors in those conversations. From there, then actions can be taken. It could be an entirely automated workflow, or we also may have manual intervention from human moderators. So to support the deep learning models and that development lifecycle, we need our data pipelines. So this is obviously a very simplified version of some of the steps in our data model development lifecycle. But the idea is that our data science team needs the ability to run jobs on demand against large data sets to facilitate this kind of pipeline. So we may have jobs that are run against large data sets to do some sort of pre-processing. We do have jobs that run our models against validation sets, large validation sets, to ensure that things are running smoothly before we deploy them to a higher environment. So data science team need these kind of data pipelines to run against data sets. So in our case, data sets could range from a couple of 100,000 records up to tens of millions. So having a data pipeline engine gives our data science team visibility into what's going on and also the ability to troubleshoot, etc. So that's where Argo Workflows fits in. So just one curious, has anybody here used Argo Workflows before? Okay, so so it's all new to anyone outside of Spectrum anyways. So there's 4 components in the Argo suite. We're using Argo Workflows, and we're using a little bit of events to describe later on. There's also continuous deployment and the rollouts, which is blue, green, and white framework. So we don't use that, but just a shout out to Matt who stepped out there. He's going to talk after this on our own blue green component, what we do with Spectrum as well. So that really is. So Argo Workflows is an open source container data workflow engine for orchestrating jobs on Kubernetes. So I think the key part here is it's native to Kubernetes. If you're already using Kubernetes, it's a really good fit. It obviously gives you familiarity, and it's easy enough to install. I guess too, it gives you all the scalability that Kubernetes provides, and also the cost efficiency too as well. So it's a good fit if you're already on the Kubernetes stack. Everything kind of seems to work fairly smoothly. So in terms of what it is, I'll give a quick overview of the core concepts here, and I'll go through a quick demo. So at its very core, a Argo workflow consists of one or more tasks in a day. Each task in the workflow basically contains a Docker image plus command or instructions to the Docker image. And so that Docker image could be something you pull down from Docker Hub, or it could be some custom Docker image you created in-house with our own custom code. We use a combination of both in our workflow. So the idea is that each task runs as a container in its own pod. So it's fully encapsulated and it runs like a pod like any other pod that you have in your Kubernetes system. When it comes to message passing in between tasks, there's 2 approaches which I'll show in the next demo. One is string parameters, which Argo takes care of passing those from task to task or from container to container. The other one then is a file artifact. So you could define an output artifact from a task and a file artifact. You could reference that in another task. Behind the scenes, Argo will take it from this pod, put it into its own artifact repository, and then place it in the pod that requires it later on. So it takes care of that orchestration behind the scenes for you. Helm then is a package manager for Kubernetes, very standard package manager. It allows you to define what are called charts, where you can encapsulate your defined YAML workflows in your own namespace. It also provides the ability for reusability. A key advantage of it is its templating or code generation, which I'll show in one of the later demos, where you can define some standard templates through a complex workflow. You can define some custom configuration, and you can, when you're having a job to deploy, and it marries the two together to create a complex workflow without you having to know all the details of the underlying YAML. So it has that templating or code generation facility. So I want to go through a quick demo now here of Argo. So let's switch over to my IDE to this particular workflow which I've created. So on the left here, on the left here, this is just a standard Helm structure. You've got your templates within there. You've got your chat YAML, which contains the metadata, and your main YAML file. This particular workflow consists of two tasks. There's a file artifact step, which takes in this path. That's a string parameter. Takes in it's basically an S3 path. This first task references the template above, which I'll show in a second. And what it does is it downloads a file from S3 and it unzips it, and then it creates an output artifact, which is in reference by the next task. This next task has the input artifact, which references the output from the previous system above. And this template then just displays the contents of the file out on the screen. So the templates are defined in this example inline. Usually you define a template in its own separate file, but the purpose of this demo, I want in the same file. So you can see here this first task, file artifact takes in a string path. Then we referenced our own in-house image that we created that has the AWS S3 CLI installed. So you can reference another image like one that has, as long as it has the AWS CLI installed, this will work. So what happens here is it will basically plug in the path here at runtime to provide it. It will copy the file from S3 down into your local path, unzips it, and writes it to this output file. So then the output artifact is just referencing the file that we just used above. And from there then, Argo will take that file, put it into its own artifact repository. Anywhere that you reference later on, it will place it where it's needed. So in this case, you can see here further down, we have referenced it in the DAG above. So now we're just going to take that artifact and put it in. What happens is this next task, again, is just using the local host image. We just do a head on that, the values I get counted, and we output that just to the screen. So the values I head count, for those that are familiar with Helm, it's taking this values file down here to find a head count to be 100. So I'll show you now how you deploy that and run this example. Switch over here to my shell. Font here is what's everyone can do here. That's all right. So I'm going to basically deploy that workflow now. And so I'm running a Helm command here. It's just installing that superset in my chart, use that values file, and deploy it to my local. I'm using Minikube here locally. It's just a local Kubernetes runtime to allow us to test it out. It's the same approach if you're deploying it onto your dev or your pod cluster. You do this via a build job, a CI job. So as you can see here, this same YAML I showed you, except here, you can see that 100 is built in by the back as well. So that just gives you an overview of what Heaven does, which I'll show later on in more detail how that's powerful. So I'm now going to invoke the workflows being deployed to Heaven. I'm not going to run it. I'm using a current command here. You wouldn't do this to deploy to run your own workflows. I'll show you how we do that later on. But just want to show how it works here. So basically, you're just invoking a web server behind the scenes. You're telling the let's get it up to the top so you can see it. The idea is that we're invoking the Argo web server. We're telling it to invoke this workflow. I'll show you later on, passing this S3 path. So when you invoke workflows, it only supports string parameters. You can pass out files, although you could pass out, what we do in some cases, we pass out a path to an S3 file, which then we use from within the Argo workflow. But this is just telling Argo to run this particular workflow. So this returned back at 200. So now I'm going to go into my Argo UI, and we should see this thing in action. So you can see at the very top, it's created a new workflow. So just take it back here. This is the Argo UI. It's a read-only UI that shows you all of your workflows that have executed in the past or that are currently executing. And it also contains like the workflow templates, the ones that we've basically YAML, those charts that are defined. There's cron jobs. It can show you events too as well, etc. But it's primarily read-only. The only way to actually generate a workflow is by creating YAML. So just to show us what's going on here, we get the visualization of the workflow. As you can see here, this is already completed. We have two tasks. They ran on two separate pods, as you can see on the right hand side. The containers tab will show you the commands that were part of the particular task. If you want to see the actual output of the job, you can click on the logs here, which is basically showing the output from that S3 file that we downloaded. You also have the ability to click on a particular pod. If something went wrong, you get this will be a red X. You could go in here and look at the logs. This doesn't work for you or something. But we in our higher environment instead, we probably know what to do it on, so and you can get the logs from that. So and that's a quick overview of some of the basics of what Argo workflows are about. So just to move on, we'll talk a little bit now about what we do within Spectrum. So we've got more than two pipelines. There are two main ones that are used by the data science team. Our data acquisition pipeline and IRO. So data acquisition pipeline is used to validate our models before they're pushed into the higher environment. So they can be run. The batch job can run on demand. So our data science team can configure their models accordingly, like new versions, new rules, etc. Test things out at scale before we push them into data pods. So it does some pre-processing, language detection, cleaning, classification, coding. It's very much CPU bound. I was quite similar, except the downloads are called embeddings. Embeddings are basically when you have an individual record or conversation, you tokenize that into individual tokens. Each token then has what's called embedding, which describes the relationships it has with other words. So that's used, this particular job is used as an input into our training process. The other one is used in validation, which is reference to the slide I had earlier on. So both of these would run, like I said earlier on, against large data sets at the very minimum, a couple of 100,000, up to, I think, tens of millions of dollars. You probably want to get to a stage where we can support 100 million at some point. We're currently working on that. And our jobs at the moment are very much CPU bound, so we need to be able to run this in a distributed manner. So this is where Spark enters the equation. So we're using Spark to run these jobs in a distributed manner within Argo. So just curious again, is there much Spark usage here around the room outside of Spectrum?
I I've used it in my previous project.
Okay, yeah, but not extensive at the moment. Yeah, so we run Spark on our own Kubernetes infrastructure, and we're not using Databricks or EMR or any of those. So to do that, we have installed a Kubernetes Spark operator, and it's a Kubernetes custom resource, and basically it controls the orchestration and the creation of the management of your Spark job. So it's a simple, I wouldn't say it's a simple installation, there's quite a bit to it. It's more probably a configuration that takes up work than the installation itself. So to show you what this is about, I'm just going to switch over again into my IDE. And basically the way it works is you provide these, this kind of a manifest to the Spark operator, which is YAML file, which describes the structure of your Spark job. So in this case, this is all templated using help. The idea is here, the main application file, for example, describes where your Spark's a bit jar file is, and sort of string, your main class to run, your arguments, and all your configuration, quite a bit here. You define your driver, how many cores you want, how much memory, some standard environment variables. So the idea here is that all this is kind of standard. At one time, you can plug in any variations that you want and create values file. Likewise, your executor is defined down here. You define like how much memory you want, how many cores for each executor, your node selector, which determines kind of the all-scale group that you're using, and how many instances, which is really important to figure out how much scale that you can support within your cluster. So the idea is that you provide this YAML file to the Spark operator, and then it takes care of everything else for you, once you configure it. That's how we run our Spark jobs within Spectrum. So I'll now give an overview of the Argo job, and hopefully that should marry some of those other concepts that I've showed so far. So I'm just going to move over here to this other repo. This is the Argo Spark workflow. So the idea is that what I showed there 2 slides ago, that like the cleaning, the pre-processing, all that stuff, that's done in the Spark job. You can provide that yourself. There's no getting away from that. What we have developed within Spectrum is an ability to create a scalable Spark cluster via Argo with a couple of lines of YAML. So for this particular Argo job, I've defined this repo. In my main YAML, I'm saying use the Spark standard workflow YAML file. The Spark job was saying use the Spark job template that I just showed. And from there, then it's just a case of plugging in your values. You create your Spark job. Now we just configure it. So for example, you're saying the job name is the location S3, where the jar file is, the main class. Process like about a milliseconds. I'll show that later on in the next slide. That determines how big your cluster will be in a dynamic manner. You define how much memory you want. At the moment, our jobs are fairly kind of linear in terms of how much, or static in terms of how much memory they use. So we can just statically provide these values for now. And then we also have some versions, like for example, this is some of our workflow code that we have, our custom code, what version of the image to use. So you define that, then you can deploy it to help, like I showed you earlier on, so to show you what it looks like after you deploy this to help. So again, it's the help command, where you plug it in your values files. So what happens behind the scenes, this complex YAML is created for you. We help marries the values file with those templates. So now you've got this fairly complex workflow generated for free without having to really know about it. So I'll show you now how we invoke that and what the actual job it does. So we've created, we don't, like I showed you around this current statement, we don't invoke workflows using that. We have created our own what's called Argo.CLI, which you can take in a YAML file. So to describe the structure of that, I'm just going to show you what it looks like. So all of our jobs that use Argo, you define a YAML file which describes basically instructions for the job. So this particular YAML is saying the text cleaner, which maps to Argo, that's the input location. Use that pack.a file, write to this one, and it's the embedding names of the embedding versions to download. So the idea is then our Argonaut CLI. What I want to say here is that I'm going to submit, and I want to pass in this path. So what's going to happen here is, behind the scenes, Argonaut's going to convert this YAML file into a protobuf message. And we use GPC and protobuf heavily within Spectrum. So it converts that into protobuf, it converts it into, it serializes it into a string, and it pushes that string up as a string argument like I showed you earlier on. And on the other side, when the Argo workflow retrieves it, it converts that string serialized protobuf back into a file which is then used downstream by all the components in the workflow, including the Spark job. So I'm going to run this in my dev environment. Actually, let's go to the local. I'll just change this into my dev environment. So I have now created, well, 1 second. Back on the API. So these are the screens. Okay, I'm back on. So I'm just on the this again, means our dev environment, we should create a workflow for us. There you go. Let's create this Argo workflow then. So I'm going to go into our dev environment now. And in here, it's kicked off this workflow for us. So I'll show one that was created earlier on for Argo. So YAML that I showed you has created this workflow, very complex workflow. Well, not only complex, but there's quite a bit, there's a fair few nodes to it. So what's happened here is this first step will take your string serialized protobuf, convert it into a file. That file is passed downstream to the other tasks in the workflow via the artifacts support that I mentioned earlier on. Workflow message pre-processing, that does some standard kind of validation and transformation of your message before it reaches the Spark job. This particular node here is the actual Spark job itself. As you can see here, it only created one instance. Well, it just created a Spark cluster of one instance with 15 cores. We also figured out down here what's the appropriate node selector to use. So I think I should be able to get an example of one that I ran this morning. Let's see, down here somewhere, here we go. This one I ran this morning. You can see here, we have 5 executor instances. So as you saw in the values file, I didn't specify how many executors to use. All that is calculated dynamically using these preprocessors. These preprocessors figure out what the appropriate size of the cluster should be in terms of how many executors, how many cores in each, what's the optimal number of partitions, what's the node selector to use. So to do that, we have generated this preprocessor code. So as you saw in the values file, I showed you this process record of milliseconds. This value specifies how long it would take to execute an individual record on an individual core. So our cluster size calculator will take that value and takes the file path which we are using as the input to the Spark job. From there, then our record count calculator attempts to figure out how many records in that directory. So it will first query our catalog, which contains a registry of all of our files that we processed before. If it's there, it uses that. If not, then it opens up the file, it counts how many records are there, and and figures out from there how many approximately are in the overall directory. If the files are too big, for example, if that one 10 gigabyte file, he's probably going to do an estimate of how many records there rather than opening up the file, doing a line by line count. So from there then, what happens is, it figures out how many records we have, how long it should take to process each record, and it figures out how long it tries to run the job in about 15 or 20 minutes. And it creates the cluster accordingly, size of the cluster accordingly. So in the previous example I showed you, it sized it at 5 nodes and that job back in 10 minutes. That's like very efficient batch job running. We're not running a 16 node cluster to do something in 2 minutes. We're not running a one executor cluster for something to take an hour. So we try to get it done in 15 or 10 to 20 minutes. But all we need to do is specify that one value, and this calculator can figure out the how big the cluster should be. Just a little bit around our SDK, what we built to simplify workflows for our developers. I showed you already about our Argo CLI. That can take in a YAML file or a JSON, converts that into the hex string parameter, pushes it up to the Argo Workflows, then converts back into the file. So when you're passing messages between tasks, you're dealing with files. So we've created our own SDK that can simplify that. So when you're writing your own code, we use Scala, and we're primarily a Scala shop, at least on the data engineering side. I know what data scientists use Python and everything, but these, like those pre-processes I showed there, they're all developed using Scala. So within that, you just define, you override a particular class, and then using a one-liner, you're able to read from the file, write back to the file, and you can just focus on your actual business logic itself. And we also have a JMX agent that publishes all of our logs from our pods to Datadog so that we can easily query and get a full view of what our job is doing. We also then have cron cleanup jobs that run in the background that can clean up. Sometimes when you stop a job, the Argo server does not kill the Spark application. So in that case, we have these cron cleanup jobs that clean up our Spark jobs behind the scenes. Lastly, down the bottom right, the minikube is really important. I have to give a lot of credit to Mark, their colleague, who set this up, and it was quite complicated to get this to run locally, but it gives you the advantage of being able to run all your pipelines locally. When you're generating complex pipelines using YAML, and you can run into a lot of indentation errors, that kind of stuff. So having the ability to get that quick feedback locally is really important. Check here on time. So just to wrap up some of the Argo workflow stuff. So the Argo Workflows has a lot of features, and the most recent release is 3.3, I think, and it has some cool features that we haven't got to yet. We're in the process of upgrading to Argo Workflows 3, but it has the ability to run this inline template functionality. So for example, you can run a command in your YAML file to invoke a HTTP web service. You can then process that again, calling it in your YAML your template. You can process the JSON and transform it some way. It also has a big feature whereby you can do transformations on files in S3 without having to write S3 code. It has this sidecar plugin capability where you can write custom plugins that will run on an individual step in the workflow. I think it's pretty cool. If you've got human intervention in your workflows, it has the ability to have workflow approves any new features. And the last one then is around these 5 artifacts that you're passing around. You have to wait in the latest release the ability to click on a file and see what's in. Excuse me. So that can make troubleshooting a lot easier than what it is at the moment. We can't click on it, you can't really see what's going on. So Argo Events is almost a sister component then of Argo Workflows. It allows you to run these workflows in a more automated manner. So what I'm going to do is I'm going to drop a file into an S3 bucket and show a workflow being invoked via Argo Events. So just let me do that. This particular command is going to remove a file from that bucket and it's going to copy it in to a bucket. That particular bucket is registered with Argo events. Argo events then will invoke a workflow, which will invoke another workflow to invoke the other one that I showed you across. This allows us to run our workflows in an automated manner without having to have our data science team run things via CLI. So probably facilitates more, you have workflows and more complex data transformations. I think this is where Argo Workflows could be good. Need to refresh my credentials here. Is that file uploaded? So while that is being uploaded, it's going to show you how this is set up. So this is another template that defines how Argo events work. So what happens here is we define this template. Down here, basically, we're passing in, when the event occurs, it creates some JSON. That body is passed to the first parameter of this template down here. This template has a string parameter, which is the event JSON, which invokes our code, our own, invokes this code, which will translate that JSON and create a pull message, which then invokes the IO workflow that I showed earlier on. So that's a pattern that we're using to convert from JSON to pull that we use in-house. So let me just go back out here to dev, and hopefully we'll see this in action. So it hasn't kicked off yet. There seems to be some delay here. We're using SQS as a bridge between S3 and Argo. So I believe there's some sort of a slight delay. So this should come up any second now. Where it will invoke the first workflow, which then triggers the second workflow, which will invoke Argo. So I'll come back to that in a second. So some of the challenges that we've encountered with Argo, it's a newer technology. So for example, if you go to Stack Overflow, there's if you use something like Apache Airflow, there's 8,000 questions here. There's a big community, a lot of examples. With Argo Workflows, it's much smaller, it's only 200 questions at the moment. Documentation is decent, but you don't have the full breadth of examples that other more mature frameworks have just yet. I think the big challenge is the Spark operator is not native to Argo. So what that means is when you look at the UI, you're seeing the orchestrator, but you're not the operator, but you're not seeing the driver or the executors themselves. You're not seeing the 5-node cluster there because it's running the Spark operator in the background. What happens like I said earlier on, when you kill workflow sometimes, it leaves these jobs hanging around. That's why we need these cron jobs to run in periodically to clean up our cluster, make sure that we don't have an expensive 16-node Spark cluster running indefinitely. I think another challenge is the YAML definitions are cumbersome. That's where the main queue setup is really important. To have the ability to run things locally without applying to dev, figuring out your indentation error and repeating. I went through that for a month or two in the torture. So having the ability to run that locally is a big advantage. I think at some point you want to get away from YAML completely and have some sort of UI, but I haven't seen a tool out there that does that. I know other frameworks like Apache Airflow use Python, which probably could be a bit better than YAML, but I haven't used it but to compare. I think the last challenge then is the platform tuning for the Spark jobs takes up quite a bit of work in terms of setting up all the scaling groups and a particular image type to use your Spark jobs. You need to set up tolerances and policies, security. It's quite a bit there, and node selectors, all this kind of stuff to get the Spark jobs to run at scale. And that could probably be a separate talk in itself. So those are some of the main challenges that we've had with Argo Workflows. It's been quite a time using it. I really enjoyed it, and there's some cool new features there, but definitely there is some challenges with it too being a newer technology. So I'm going to switch back here to Dev to see if, yes, the orchestrator, let's just put it over here. So you can see here, this Argo events orchestrator reacted to the S3 event. So down here, we created a JSON file. You can see here the bucket name, where we uploaded the file. We also then have the key, which is the actual file itself. So like I said earlier on, this code is our own custom image, whereby we translate that message, that JSON into a photo, and we then invoke our show here. We invoked this thing kicked off 2 minutes ago. And so now it allows these workflows to run in on it. So we haven't done much of this so far. We're starting to roll it out, but I think we'll give a lot of benefits to be able to run these things in an automated manner. So I think that concludes what I wanted to share with the Argo workflows and events, hopefully. You got some idea what it's about and how it all works together. So any questions or comments on what you see there?
So I have used Airflow.
Oh yeah?
Yeah, in my previous project, and similarly, Spark on Kubernetes operator.
Really?
To basically trigger the job. I think since it's open source and community, a lot of people are there. I think Argo is also, right?
Yeah.
They added the support for like there's already an operator that I can use for running Spark on Kubernetes jobs. So I have to just define a YAML template, the one where you showed the drivers, class, executors, and it just does the thing for you.
Is that what in Airflow?
That is an Airflow.
Okay.
Yeah. And the thing that you showed for events, S3, Airflow has something similar called sensors.
Yeah.
So it picks it up from there. The cool part that I like is the auto-detecting of the cluster size. That is something native to Spectrum, right? So Spectrum has built that particular piece. Right?
Yeah.
So I was curious, like, while choosing Argo Workflows, did you get a chance to look at Airflow at that moment, or?
I didn't. I think this decision predated me. I think before I joined, there was already a decision made. I don't know whether, if you recall, why we chose Argo, but I think that decision was made later on because we were using Kubernetes, and so I identified that going to be a good fit.
Also, we had some difficulties in actually before.
Okay.
You did see also because I did work with I set up the workflow, the infrastructure side of it, and then the issues that we are having is that obviously Argo also runs in Kubernetes.
Yeah.
But we have more control because Argo is Kubernetes native compared to Airflow.
Yeah, so I was actually running the thing that you showed, where like pod comes up and goes. We are using Kubernetes pod operator and Kubernetes executor.
Yeah.
So that actually helped us to make dynamic compute and have the pods come up and go at the same time.
Yeah.
But then I didn't use any hem combination with it. So those are just tags that we wrote, and the tags were automatically synced by using a git sync operator. Whenever you made some changes, it was automatically synced obviously. Yeah.
So how complex was I'm guessing, deploying Airflow onto Kubernetes? Is there much complexity there?
There wasn't. I would say that initially there was complexities with Airflow version 1.0, but right now with Airflow 2.0 and 2.3 is the new one, or 2.5 is the new one, it has become much more easier. And like you said, if you go and search on Stack Overflow, you can easily find answers for Airflow. There's a big community. There's Slack channel is pretty responsive, and there's a bunch of things around that.
So, Melvin, how complex would you say the platform side of setting up? Well, the workflows was straightforward enough.
It is straightforward.
I think the Spark stuff is more complex,
Like Spark is because internally the Spark this is not Kubernetes native, right? So we need to need to debug that.
Yeah.
Because especially when the executor runs, we cannot find the driver.
Oh, okay.
So every time when we put it in the first version of it, we have a lot of phantom objects that are running and never dies.
Yeah.
And since it's not communicating, like the drivers are communicating with the executor, the result is not being processed properly. So we had a lot of issues with it. So I had to now look at the actually the code.
Yeah.
How the Spark was actually communicating internally, and there's a lot of things that we had that we don't have in Kubernetes that we have to enable.
Yeah, I think there is a Spark operator also that is there as part of Airflow, but we were using directly the Spark on Kubernetes operator.
Okay. Same thing.
Yeah.
Okay.
And as far as I remember, like initially there was another open source tool that you guys were using, it was Hyperion, right? Is it still being used or?
So,
Hyperion.
We're not using that.
Oh, you're not using it anymore?
no. How did you find the operator? Like, what kind of scale did you have your dispatch jobs?
What kind of, sorry?
And how big were your clusters when you were running your dispatch jobs?
Well, we were running multiple jobs. We used to, like, the usual ETL process was like, clients used to upload data in Google Cloud Storage, S3 or Azure Blob Storage. Pipeline needs to run, convert the data sets into Spark format, extract the attributes out of it. There was like, we had k-mean clustering and there was one more in there. Frequent pattern analysis.
Yeah.
So all the things we were doing on top of the data. So all those were Spark jobs that was running on Spark Plus, on Kubernetes. Usually the clusters were of size 10 node cluster and stuff, but then it was all ephemeral. It just comes up and like Spark on Kubernetes, like you start the job and it automatically cleans up after the thing.
Yeah.
So Airflow already does the cleanup. There's one set of one value that you need to set, and it will automatically clean up the things.
Sounds clear as much.
Yeah, like, I was curious, like how did you guys decide on like Airflow versus this one? That's why.
That's probably a question for Josh. Yeah, but I think definitely the fact it was Kubernetes native was an advantage. I think it was an advantage.
Thank you.